a favorite demonstration that I do in the classroom is I take a pyramid and fill it full of beans, tiny little beans, or even sand or something like that. And then I pour it inside of the prism that has the exact same base and the exact same height. And I wish I could do it for you now, but I think what you'll see by this picture is really the emphasis of what everyone gets eventually, is that when it fills in that space, it doesn't fill the entire space. All it fills is exactly 1/3 of the space. So if I was to pull this guy out and fill it with sand and then do it a second time, we would fill up to about 2/3, well, exactly to 2/3 actually, would be where we get to. And then if we were to do it one more time into there, we would fill the remaining amount. And so we learn from that informally, and there's obviously a better way to prove it, but we learn a sweet little connection between something we know, which is prisms, to something that's new, which is pyramids. And the only thing you got to keep an eye on is that it will be exactly 1/3 of that volume of the prism. And we use that to calculate pyramids. How cool is that? Pyramids also are a little bit different in shape, so let's talk a little bit about some of their names. A face refers to the entire, what we usually would call like a side, but a better name for it in a three-dimensional environment is a face. This is a face. And again, as we've talked about with prisms, there's a base. So in this case, this is the base face here. Happens to be, I think, well, normally it would tell us whether it's a rectangular or a square, but usually it's probably a square. This would be a square pyramid per se. A vertex is when we come to, three where the edges all meet. This is actually often called the apex of the pyramid, the top point. Edges, of course, are where two faces meet, and all of those things. The one thing I maybe will just take a minute to talk about, because it has so much to do with the tricks of the trade, a lot of your work will be found in this triangle right here. Now, sometimes they will give you the height, and life will be simple. Usually they won't. This guy right here, this length out here on the face, is known as the slant height. So it's not the height of the pyramid, that's this guy, that's the height of the pyramid, but the slant height is out on the face. And usually we use this right triangle to find the height or calculate some other aspects. The other thing maybe to tell you is this side right here, if this was a square, half of that would give us this length right here if needed. Lots of cool little tricks about this shape. All right, let's look at this. So it does tell us it's a square pyramid. Immediately with a pyramid, I write down 1/3 BH, again, where B is the base. Volume equals 1/3. Now the base is a square, so that's just simply 8 times 8. And the height is given. There it is. This is 213 1/3 centimeters cubed, or 213.333. Repeating. But basically all we did is we took this guy, we multiplied by the height. Now again, remember, there's this pyramid that exists, this prism that exists, and our guy is inside of that, right? And so that's why we have to do the 1/3 of that, because if we just did BH, we would be finding the full region here, all of that. And we're not interested in all of that. We want only 1/3 of it, and that's how we work this out. Again, we're told this is a square pyramid. A couple things are missing. Actually, let's zoom in even a little bit further here. Let's get in nice and close. Now, this here is half of this guy, and we know that because of the square, so that's going to be a 3 down here. They do give us the slant height being 5, and this is a little bit of what my pre-warning was about, is notice I need the height and it's missing. I am aware, though, and I hope you are, of a Pythagorean triple of 3, 4, 5. So our height is a 4. Now we can go back to the business of solving this guy. Volume of a pyramid is 1/3 BH. Don't forget that 1/3. The base is a square, so it's 6 times 6. And my height happens to be a 4, which is a pretty little number of 48 centimeters cubed. And again, what I did is I found that base. I multiplied it by the height. Now that, of course, is these two parts. And then I divided by 1/3 to obtain my answer. My third and final answer is kind of was a tricky one for me to draw dimensionally so that you would kind of see it. Let me see if I can help out. The base is this triangle right here, this right triangle. And this is a pyramid because it comes to a point, but our base is not a square. It's a triangle here. So volume still is 1/3 BH. Our base, though, happens to be a triangle, which would be 1/2 base times height. You say, where did that 12 come from? I'll tell you in a minute. Where did that 12 come from? 5, 12, 13. There's our Pythagorean triple one more time, showing up almost every other question. All right, and you just slam all that together, and amazingly enough, that just becomes 100 centimeters cubed. What was a little tricky is that dimensionally that was kind of a hard thing for you to visualize. The base was a right triangle, but after that it's simple.